Now in this lesson, we're going to be looking at advanced cases of factoring by grouping. So all this means is we're going to look at factoring by grouping, but focus on more challenging type of questions, more challenging type of problems. Now, how we're going to go about this, we will start by reviewing factoring binomials using the greatest common factor method. We will also review the difference of two squares. We'll review sum and difference of cubes, and then examine the steps, and then we'll walk through some examples together. So when we're factoring binomials using the greatest common factor, we want to find out how to do that. And to do that, we're going to divide each of the terms by the greatest common factor, and then the leftover or the other factor that is generated becomes what forms the binomial here. So let's look at 4x plus 28y. 4x, I'm going to just go elementary here. This is a review, so I want you to follow through just in case you haven't watched the other video you haven't taken the other lesson that has the introduction to this topic. So 4x is equal to 2 multiplied by 2 multiplied by x, and then 28y is 2 multiplied by 2 multiplied by 7 multiplied by y. So now our greatest common factor is going to be the term that appears for both of them, 2 and 2. We can't see any other common terms. So 2 multiplied by 2, which is equal to 4. So now when we want to rewrite 4x plus 28y, what we're going to have is greatest common factor is 4. Now for 4x, the only thing that is left, the only other factor there is x. And then for 28y, the only factors there are 7 multiplied by y, which gives us 7y. So this is how we get to this result for 4x plus 28y. Now we want to look at the difference of two squares. When you have two squares, so this x squared and y squared, this represent perfect squares. So all we're saying here is that if you have perfect squares and there's a difference of two perfect squares, you just have x plus y multiplied by x minus y. Now for sum and difference of two cubes, let's focus on the sum first. When you have the sum of two cubes, it's going to be x plus y multiplied by x squared minus xy plus y squared. And then for x minus x cubed minus y cubed, you have x minus y, x squared plus xy plus y squared. So if you observe, you can see that when you have a sum of cubes, you have your x here represents the sum, and then you always change the sign in front of xy. So you notice that they always alternate. And then when you have x cubed minus y cubed, your sign here shows that there's a difference, and then your sign in the middle here alternates. So I'm going through all of this because we're going to use them for some of the examples we're working through. So let's look at advanced factoring by grouping. So the method is still the same as your regular factoring by grouping. You want to first express each term so that you can find the greatest common factor, identify the greatest common factor, combine the other terms that are not part of the greatest common factor, and then in this case we're going to keep factoring until we get to the simplest terms or the simplest forms. Let's look at this example. Let's look at this example now. We have x squared minus x squared multiplied by x squared minus 9 minus 4 multiplied by x squared minus 9. So you can see that x squared minus 9 is our greatest common factor. So let's go ahead and write that here. X squared minus 9. And then the other factors are x squared minus 4. Now let's take a look at x squared minus 9. X squared minus 9 is the same as x all squared minus 3 squared. So now you're going to have x plus 3 multiplied by x minus 3. Now x squared minus 4, you're going to see that that is the same as x squared minus 2 squared. So you now have x plus 2 multiplied by x minus 2. So now we're going to replace each of these terms with their simplified form, with their factored form. So x squared minus 9 is x plus 3 multiplied by x minus 3. And then x squared minus 4 is x plus 2 multiplied by x minus 2. So that is how you do that. Let's try another example. So in this case, we have 4x multiplied by 4x squared minus 25y squared plus 16 multiplied by 4x squared minus 25y squared. So our greatest common factor is going to be 4x squared minus 25y squared. So we're going to write that out first. 4x squared minus 25y squared. And then the other factors are 4x plus 16. Okay, so let's go ahead and look at 4x squared minus 25y squared. So we can rewrite this as 2x squared minus 5y squared. So using our difference of two squares, this is going to give us 2x plus 5y multiplied by 2x minus 5y. And then 4x plus 16, 4x plus 16. We have a greatest common factor of 4. And then if we divide 4x by 4, we are left with x. 16 divided by 4, we are left with 4. So now, this is how we're going to rewrite this. I'm going to start from 4 here. Then this is going to give me x plus 4 multiplied by 2x plus 5y multiplied by 2x minus 5y. So now this is our factored form of the original expression we had. Now let's look at this example here. We're starting with this expression. So we have 3x multiplied by x cubed minus y minus 12 multiplied by x cubed minus 1. So let's go ahead and take note of our greatest common factor. That's going to be x cubed minus 1. So we're going to write this as x cubed minus 1, and then our other factors are 3x minus 12. Okay, so let's go ahead and simplify x cubed minus 1. The difference of two cubes is going to be, we're going to pay attention to this, is going to be x cubed minus 1 cubed. And here's the formula, just in case you've forgotten it. It's x cubed minus y cubed is going to be x minus y multiplied by x squared plus xy plus y squared. So therefore, x cubed minus 1 is going to be x minus 1 multiplied by x squared, and then x multiplied by y is going to be plus x plus 1. So now we're going to replace, and then let's focus, before we go ahead and replace, let's focus on 3x minus 12. You're going to have a greatest common factor of 3, and then you have x minus 4. Okay, so now let's go ahead and replace. So I'm going to use 3x minus 4, and then x minus 1, x squared plus x plus 1. So this is the final factored form of the expression we had to start off with. Now the final one that we have, the final example that we're going to walk through, we have a greatest common factor of x to the power of 4 minus 16. So let's take note of that, x to the power of 4 minus 16. And then we have the other factors are x to the power of 3 plus 1. Okay, so a few things we want to note here. X to the power of 3 plus y to the power of 3 is x plus y multiplied by x squared minus xy plus y squared. Okay, and then a squared minus b squared is a plus b multiplied by a minus b. So in this case, we're going to look at what we have to do. So let's pay attention to x cubed plus 1. X cubed plus 1 is same as x to the power of 3 plus 1 to the power of 3. So let's go ahead and simplify. Let's substitute this in here. So this is going to give us x plus 1 multiplied by x squared minus x plus 1. And then x to the power of 4 minus 16 is the same as x squared to the power of 2 minus 4 to the power of 2. So this is going to give us x squared plus 2 multiplied by x squared. Actually, that's not correct. It's going to be x squared plus 4. X squared plus 4 multiplied by x squared minus 4. Now we have a problem because x squared minus 4 is also a perfect square. So x squared minus 4 is the same as x squared minus 2 squared. So that's going to give us x plus 2, x minus 2. So now we're going to rewrite this using all the factors that we've been able to derive. So x to the power of 4 minus 16. Let's go ahead and do that. That's going to give us. So we need to pay attention to the details here. So let's start off with x plus 2, x minus 2. So x plus 2 multiplied by x minus 2. And we can't forget x squared plus 4. X squared plus 4. And then x cubed plus 1 is going to give us x plus 1, x squared minus x plus 1. So now let's go ahead and rewrite this so it looks very clean. So I'm going to start with the linear expressions first. So I'm going to start with x plus 1 multiplied by x plus 2 multiplied by x minus 2 multiplied by x squared plus 4 multiplied by x squared minus x plus 1. So this exactly is what you need to do when you have more advanced topics or more advanced expressions that you need to factor by grouping.